Hey there! My name is Brandon Howe, and welcome back to my Making a Game series. In the last episode, we finished off our game in a demo sort of way. We turned our game into a executable file to be able to be run outside of Unity, and basically finished off the series with that. Now, however, I'm returning to this to turn our demo into a releasable product. I'm going to be extending the series a bit longer to do that, to sort of add a few more things and make this more into something playable and presentable, I suppose. So let's get started with that. The first thing that we're going to be working towards is being able to make more levels. Now, we already had 3 levels here in our demo type thing, but these were kind of tedious to make. There was a few problems with them and yada yada yada. Making 15, 30 levels by just duplicating enemies all over, I think we can do something a little bit better. So I've gone and started making a level creator system, having a level creator game object with a lot of different parts to it and a really long script that can help us basically just a whole bunch of numbers and generate our levels for us to an extent. Now, I was going to try and make this in a video, but that turned out to be way too complex and difficult to do. So rather, I'm just going to go through this and show how it works as if I'm making it initially. So before we get started with that, a few other changes that have been made. In our manager's game object here, what was once our enemy manager has been changed to pickup manager, which required changing the name of the game object here, the name of the script in the editor, and the name of the script in the script itself. So changing those 3 names and making sure not to misspell anything was required to get this to function properly. As well, any other scripts that were to reference this, changing those names as well. In addition to that, going to some of our prefabs here, our enemy prefabs, I'll go into the enemy turn, for example, because the Y component doesn't really matter for the context of our game. I've gone and stretched up the colliders on all of them because some of them were a bit too small, and as you'll see why with something I've done with the level creator, I've basically just needed to extend the colliders far beyond where we'll need them. So I've done this for all 4 enemies. In addition, for our enemy shot, I've gone to be able to stretch that up as well. I turned it into a box collider instead of a cylinder collider. So yeah, I've gone and done that as well. Making sure that the collider is added on the same game object, not because we have 3 different game objects here, well, 3 different sets of parents, children in there, so making sure to put the box collider on the same game object that once had the cylinder collider, so that goes accordingly. As well, I turned the level end into its own prefab, so that it can be spawned in by our level creator, as well with the turn trigger, but that was already set up that way. As well, the player shot, I did the same thing that I did to the with the enemy shot with the cylinder collider, so that's that. So let's get into our level creator. Actually, first I'm going to show off what it looks like in our play mode here to help better visualize it when what it's doing when I go into the code. So this here is a level that has 3 waves set up. Each wave. So this is like how you can have arrays of integers or strings or arrays of any variable. You can set up, actually I can go into my code to show off this. You can create a separate class, which I've done called wave, and then have an array of that class, and that's basically a way of how you can have an array of a bunch of different variables. So I've tried not to get too complex with the coding practices I've gone through making this, trying to keep things a bit simple, but doing this made things a lot cleaner in terms of what this looks like in the inspector, so I went with that. So we have a few different variables here. So also each sort of enemy chunk is denoted as one wave. That's how I've set that up. So setting how many waves there are, going into the information for each wave, the rotation determines what way the ship is rotated for that wave. So it'll spawn a turn point right before that wave, which is going to be going up or sideways or on an angle, and that's how that's set up. This rotation goes in multiples of 45. So 0 will be going straight up, 1 will be going 45-degree angle, 2 will then be 90 degrees, and you'll go around in a circle like that. So that's that. As well, distance to next will be the space, like how many units between when this wave ends to the start of the next wave. Now, these X-min and X-max variables, basically how these enemies are spawned. Oh, as well, num enemies of all these, that's how many of each enemy are in each wave. And then they get basically randomly spawned in this this sort of box area. And then how that's done is with these X-min, X-max, Y-min, Y-max variables. Basically, at the start of a wave, we have a private like X and Y position, kind of like almost like an empty game object, but just stored through code that goes to like the bottom left corner of this sort of box. It'll move over a random X value based on the X min and X max, so between 2 and 4 units. So it'll move over that much, and then Y min and Y max, it'll move either up or down, in this case between 1 and 3 units. So let's say it moves up 1 to 3 units. And then it'll spawn an enemy there, and then it'll go back down to that same row it was going across, and it basically keeps going over random X amounts and up and down certain Y amounts, but then going back down to the Y amount it started with, all the way over till it gets to the end, to what the boundaries were. Then it goes back over to this side, and then goes up a bunch, and it basically goes over like that, each time spawning in a random enemy, as well doing things to make sure it doesn't spawn on top of another enemy, so that enemies aren't spawned intersecting each other. As well, something to deal with our turning enemies, them moving back and forth. What I've gone and done, which is the reason why I extended the colliders, I've actually bumped up where all our turn enemies are spawned, and bumped down where our enemies that just move straight are spawned. So they're actually kind of spawned into, almost 2 layers, sort of. With the way the camera's oriented, it looks just fine. It doesn't look like they're up too high or down too low, but these enemies are able to go over these enemies without intersecting them, and it looks fine there. So that is how this is set up, and if I pause this and go back into it in a second, you'll see that it spawns sort of the same thing, just these enemies. In each wave, the enemies are spawned randomly, which is good. It adds more randomness then to our levels, which is good, while making sure to add the same amount of enemies. So the score is still fixed of how much you can get, and it's not that random. As well, in between each wave, the turn triggers are spawned. I've also stretched out the colliders for them. And then when it gets to the end of the last wave, it spawns the level end thing. So that is how this level creator is set up. As well, then a bunch of variables here for all the prefabs that get spawned. Well, also the parent game objects that we spawn the enemies under, just to have more organization in the editor here. So as well, then the prefabs of the different things that we're spawning in, which is why I also had to make the level end a prefab. And that's that. So now let's finally go into the code and see how this thing works. So actually, I'm just going to go out of play mode as well. So for starters, as I've already introduced, this waves variable, it's in order to create it, everything in what we have in our code. So for example, I go to this pickup manager, everything is in one, like everything in our code outside of the using things are inside a class that has the same name as our file name, and that's what gets run by Unity when you have that class on a game object, it'll look for the class with the same name and run its start, update functions, all of that. Now, in a script, you can actually create multiple classes, and Unity will only run stuff with the class that has the same name as the file name. So yeah, but you can have multiple classes and then have them connect and have references between each other. I could have, if I wanted to, made this class its own script and then had this script get a reference to this class, as we've done in the past with, for example, how our pickup manager gets a reference. Okay, this one doesn't. How we've had like the game manager get reference to different game objects, like here. So that is one way of doing it. But with this level creator, because all this class is a bunch of variables, just having it be in the same class makes it more manageable and organized as well, so that this waves thing will appear as public in the editor. Just making it public isn't enough. Unity still won't show it. In order to make it so it will show it at the beginning of the class, adding this line here between square brackets, system.serializable, that will make it so that it'll be shown in the editor when you set getting a reference to it to public. All right, as well, just a bunch of default values there just to make things a bit easier. All right, moving on from that, these variables are the public variables that I've already explained. These are all the references in the editor that we've explained. Now moving forward, I think I'm just going to go straight into the code and explain these variables as they show up. But for the most part, the names kind of dictate what they do. Actually, yeah, this enemies left has to do with, it's an array of length 4. So basically 4 different integers that show how many of each enemy type is left as we're spawning them. This variable enemy types left has to do with spawning a random enemy out of only the enemies that we have left to spawn, the enemy types that we have left to spawn. X radius is has to do with how much space we have left and right to spawn our enemies, because when we have different rotations, that will change. Like how when we're moving straight up, we have a lot more space left and right, but if we're sideways 90 degrees, then we have a lot less space to work with to spawn our enemies. So that's keeping track of that based on the rotation. These spawn coordinates, spawn position X and Z, those are what we move around to determine where we're going to spawn our enemies in that box-like area. And then Z row position, I forget where I used. Oh, So when we're moving along left to right in rows, this is Z row position is where we. Actually, I should save that. I should change that to 20, but that shouldn't matter in the where it gets used. But this determines in here when we're moving left to right. Z row position keeps that Y position at a constant as we're moving left to right, moving up to spawn an enemy and then moving back down to that base level, or moving down. And then when we get to the end and move back over, then we move up a fixed amount. And basically, so we'll keep moving across in that row style. And this while counter is a thing that might not be completely necessary, but having a while loop in here, it's just a safety measure to make sure we don't have an infinite while loop run, because that basically can cause the game to crash, and we really don't want that. So that's just a safety measure. Now finally getting into the code here. So all this is running on the awake function. It's running before the game actually starts, going and spawning all these enemies and setting things up so we can have a level, everything else work as it should, under the assumption that everything's already spawned in as it was before when we didn't have a level creator in the first place. So basically awake runs before the game actually starts. So now we have a for loop here that goes from int I equals 0, I is less than waves.length. So it's going to run for however many waves we have. So in this case, if we have 3 waves, everything in the for loop is going to run 3 times, and that sort of thing. So first of all, at the beginning of a wave, we're going to spawn in a turn point at our X, Y, and Z position. Quaternion Euler. This rotation basically making everything turned downwards, so that all these things that are actually none of them are spawned in here, but everything is then moving towards the player as we've had already set up. And how we've done that. This needs a rotation in quaternions. And basically how we're dealing with that is having new vector 3 0 180 0 quaternion.Euler turns it into a quaternion, which is the measurement that rotations are dealt with in Unity. And then having this turn points parent so that it gets spawned under here. This turns trigger game object just for organization as well. This is something that could be split into two lines, but something to just make it only be one line, just to be a bit tighter, I guess. More organized. So after instantiating this whole thing, after all of this, putting dot get component turn trigger to get a reference to that, and then as opposed to saving all this in a game object and then using it, because we don't really need to save that information, we're straight away getting the turn trigger script, getting its Y rotation, which is from that script what direction we're turning the player, setting that equal to the rotation set in the wave variable here, multiplied by 45 as such. Then determining our X radius based on our rotation. This was mainly just playing around with numbers and seeing what worked. So if the rotation is 0, 4, or 8, so it's going up or down, then our X radius is at its largest, so setting that to 10. Otherwise, if it's any of the 45 degree rotations, then setting it to 7 just seemed to be the number that worked fine. Otherwise, so this would be the case if we're going left or right, setting it to 5, and that's the number that worked for that. Next, setting up some other variables before we get into spawning our enemies. Setting up the X spawn position to the negative of the radius minus whatever this min X value is. So treating it kind of like a square that we're spawning our enemies in. Basically, we're moving this position to the bottom left of the square and then over a little bit more. So then we're determining, putting all these, how many enemies we need to spawn in the enemy's left thing, because this will slowly decrease until all of these are 0, and then we know that we've spawned all of our enemies. As well, then setting the Z row position there. Now we're finally at our while loop here. That is the main bulk of spawning in all of our enemies. So it's going to keep continuing until there's no more enemies left to spawn. As well, we have this while counter here set to 0, and every time we go through the while loop, we increase it by 1, and then seeing if it's ran 10,000 times. Then we can guess that it's running infinitely, and then exit the loop automatically based on that, as well printing out a message saying that for debugging purposes. Yes, so where are we? Here. So now we set our X position by moving to the right a random amount based on our X min and X max value. Then we determine if the X is greater than the radius, so if we've moved too far to the right, then move back to the left, the same calculation here as up here when we set its starting value. And then moving up the Z position 2 times the min, that number it works enough. Then whether we do this or not, setting our Z position then to that Z row position, plus again the moving up or down a random amount based on a min or max, And then this calculation here basically generates a random number of -1 or 1 exactly. So this will either be 1 or -1. So yeah, random number between 0 and 2. Remember that when dealing with random.range with integers, it'll go from 0 up till this number, but not this number. So this will be a random number of 0 or 1, multiplying it by 2, then subtracting 1 from it will get us a number of -1 or 1. With floats, so decimals, like this, it'll be any number between this and including that. So that's how that works there. Next, to determine which enemy of the 4 that we're going to spawn, first we set this enemy types left equal to 0, then run a for loop 4 times because that's how many enemy types we have. Then if enemies left, if however many enemies left of that this 4 integer array, if it's not equal to 0, then add 1 to our enemy types left. So this is determining, how many enemy types left we have to spawn. So for example, 2. Then creating an int called random enemy, setting that equal to random.range, 0, and enemy types left. So if there's 2 types of enemies left, then it's going to generate a random number between 0 and 2, which would be 0 and 1. Then we create an int enemy to spawn, setting that to starting it off as -1, because then we're going to add to it to determine, basically after generating a random number of how many enemy types are left, then we're going back through and finding out which enemy type that is referring to, by again ignoring the ones that are zeros. So going through 4 times again, because that's how many enemy types we have. If that enemy type is not equal to 0, then increase that enemy to spawn variable, and then seeing if this and this are equal, then we're at the enemy type that we want. So we set it equal to the actual enemy type number in the list, and then break exits the for loop completely. Now that we have the enemy that we're going to spawn, now we see if there's already an enemy in this spot. And then if there is, then we are going to skip this and move on to the next iteration of moving over and up. So in order to see if there's already an enemy in that spot, we create this function here, physics.overlapBox. That's going to return an array of colliders that is all the colliders that we're intersecting with. Basically, we create a box, and if it's overlapping with any colliders, that's going to be returned into this list. If the list is empty, that means we're not colliding anything, which is what we want. So in that case, we're generating this list and then seeing if its length is equal to 0. This list that we're generating then is our coordinates that we're now spawning the enemy at, this and this. We're seeing if that's our center point. How big the box is, this list, how big the radius is, this amount, 2, 5, and 2, which the 5 is then, is that y-axis, and then 2 and 2 just worked out nicely. Quaternion identity is just a rotation of 0, 0, 0, which is fine. So if there's no enemy here, that means yes, we can spawn an enemy. So now we look at what our enemy spawn variable is here. And actually, now that I'm looking at this better, I think we can take all of this and put it inside here, because we'll want to test whether or not we can spawn an enemy before determining which enemy we're actually spawning. That just seems a bit cleaner there. So make sure that's not breaking everything. Let's get rid of that space there. So now we determine which enemy we're spawning and then spawn it accordingly. Some enemies being pushed down and others being pushed up, and then also turning their rotation so they're facing downwards towards the player because that's the direction they move, and then setting the parent to that enemy's transformed, and then whatever enemy type we just spawned, decreasing 1 from enemies left, getting us closer to 0, and then increasing the while counter. So now that we're done the while loop, seeing if it's basically caused an infinite loop, and then just breaking out of the other for loop, basically just ending this if a while loop has happened. Then resetting our variables here, this equal to 0, this moving up to the start of the next wave, this being 0 out, also by being centered is then the position that we want to spawn in the turn point. So that does that. So then these variables are set up for the next iteration, for the next wave. And now when we're done all the waves, then we want to, where we've just moved up, we want to then, instead of starting the next wave because there is no more waves, we then spawn the level end in that position. And yeah, that brings us to the end of this. So that's how that works. Saving the few changes I made. Going back in here, waiting for this to load. So now I've set up as a sort of test 3, if I can load this up, 3 test waves. One that's going forward and spawns only the asteroids and the shoot enemies. One that makes us go sideways and spawns only the both types of turn enemies, the turns and the turn and shoots. And then a third wave that has a bit of everything, and then also has this on a 45, as well, just having different, actually basically the same X and Y values. But we can, basically increasing or decreasing these is more or less going to affect the density of the wave, of how like spread apart the enemies are. Yeah, so let's test this again in this state. All right, so as well, from the level end, yeah, being spawned in, this still works accordingly. So now we have our enemy, our first wave there of just enemies that shoot, and our asteroids there. And if we die and respawn, they're now in different positions, but still the same amount of enemies. So that's nice and handy dandy there. We finish off that. We start the next wave being sideways. We have our turn enemies here. And even though they're slightly bumped up and bumped down, they still look fine there. I'm going to try and make my way through this, getting to the next wave. Or not, apparently. Oh, well, that's fine. So, then in the last wave, I've already tested this before, then we successfully turn the 45 degrees, and these enemies having equal amounts of both, as well, enemies that are kind of, if I can move over here, are enemies that are sort of on top of each other, like this turn enemy and this asteroid. It still looks fine, they're not intersecting, and yeah, it works a-okay. So there we go. That finishes off this level creation system, and that'll end off this episode. Next time we will use this to start making a whole bunch of levels. I think we're gonna go for 15. Doing some calculations based on how we have this set up. We have 4 types of enemies being combined in different waves of how many there are in each wave. That alone has like 15 base combinations of having like one or entire wave of one enemy, or like a few or like having any 2 enemies or any of the 3. That's 15 that's 15 base combinations already, as well having just different amounts of each. Like if you had, like for example, this wave that has like half shooting enemies, half asteroid enemies, you could have like a low amount of these enemies and then a high amount of these. Basically, each enemy type in a wave, there can be 3 densities, or I guess kind of being low, middle, high. Running that through everything means that there's 96 combinations of those, including that you could have 8 different directions. That's 768. So that alone, that math was not necessary, but that alone shows how much potential we have with this. you can create lots of different levels with this. You could even then add more enemies or whatever, that sort of thing. I don't think I really will for this, but yeah. Anyway, so in the next episode, we'll be making that. I think we're going to go for 15 levels, maybe 30. We'll see. Then we'll integrate that into our level select. As well, there's a few more things I'd like to add in terms of our power-ups. Yeah, but we'll see how that goes. So yeah, that'll do it for this episode. Thank you all so much for watching, and as always, have a good day.